that the displacement of an object.
So, okay, guys, you are welcome once again
To
to
the real depth
the
minus
15th day of
apparent
this
depth. Junior classes
take
way
down on
is also
physics
good. So
topics.
you can get
We are
any
into
of these
the
first. If you get any
dispersion
of
of
these,
light
then you can
and
now get
electromagnetic
the other one, then
waves.
substitute, you have your answer. If
So
you want to get
this
answer
video
directly,
concept
you can use this
cover
one, you are going to have your answer. So
quick
the lead is
revision
also called the
on what you
thickness
have studied
for the sake of those
before, and if not,
that
if
cannot
you
use
are yet to
corresponding
have
grammar.
an
So
idea
let's
about it,
just use
I'll be
that to
taking you
now. So
through
that's the first case whereby the
1, 2,
displacement is
3,
always. For the
4
second case,
points or
when
important
observer
points,
is
like I
flat
do
and what
say,
object is up, it is very,
maximum
very
in
different.
depth of
The case 2,
knowledge
this will not work.
in
But
minimum
for
possible
your
time.
level, you can see
So
directly
we
they do the
start
balance
with
block.
the
This one is
topic
under.
of
So,
dispersion
but
of
for the
light
case 2, for the case
and
of the new method
electromagnetic
that are coming, the
waves.
displacement
Now,
when
the
it is
first
upside down,
question
you
is
understand what I mean? Object is up, observer is
the
flat.
arrangement
The
which
displacement
is
is always
used
given as,
to
I will tell
obtain a
you,
pure
although you may not
spectrum
see it
of
in your
white
text material.
light is
So
that.
that is why I'm here.
Now,
So this is
we
equals
have
to
to
A
understand
of
what is
depth.
called a pure
Then
spectrum.
you
Now, we
say
define pure
open bracket,
spectrum
the refractive index mu
as,
minus 1.
you can
So
just
keep that
write
in mind. This
pure
is also very good
spectrum
for you to know. And always keep these two formula in mind. My concept video has actually explained all this
are
in details.
those
But for your
light or are
examination,
those
like I do
lights
say, this is enough for
in
you to actually
which
get what you want in your examination if you follow it from A to Z.
colors do
Now,
not
back
overlap.
to business. In this question, object is placed directly below observer. This is the case. If the thickness is 3, real depth is 3. Calculate the lateral
So
displacement.
when you produce
Displacement
light or a
for the
spectrum
refractive
generally are
index is what?
called
Mu is
light,
1.5. So
and the
directly
colors
I
in
can
them do
substitute
not
here. Real
overlap
depth
each
is
other. They will not
3
superimpose. You say it is
open
called a
bra
pure
1
spectrum. Then
minus
to
1
achieve
over
this important point,
1.5 is the same as 3
short
over 2.
concept
I hope
that
you
you
don't
need to
understand that
understand to
mathematics.
pass your
On
examination is that
simplification, this is
to
3
produce a
open bra.
pure spectrum,
This
you
is
need to occur
1
a
minus
monochromatic
2 over
source of
3. What
light.
have I done? I have
A
only flipped 3 over 2
monochromatic
because of 1 that is
source
opposite to 2 over 3. So directly I can say this is 3 multiplied by
of light.
1 minus 2
So
over 3
that
is
is the
1 over
first
3.
similarity.
I
Now,
hope you
what is an
understand that.
example of
Just here
monochromatic?
stuff.
Mono means
So
one.
on simplification,
So
3
a
times 6
light
over
that
3
is
is
said to
going
be
to give you 1,
monochromatic source
which is
is
the
the white
question answer.
light,
So 1 centimeter is correct.
which
But
is
the
the basis
spaces
of
of
this
and that is
topic
stress.
that we are
So
talking
this is
about,
the way
white
you solve. And
spectrum,
if you want to
but we
use
like to say
the
white
traditional
light.
method
I hope
of
I am
real
communicating.
depth over
So
apparent depth,
white light,
1.5
you take
equals
a
to
white
3 over
light.
x.
Then the next
Set
thing you do
apparent
to
depth.
have a pure
After
spectrum
getting it,
is
you come to a
you are
displacement
going to
discrete
use
exponent
a
as apparent depth.
triangular
Then you subtract,
prism.
and you have the
Now, it
answer
is the
3
topic of
minus 2,
dispersion of
which is going
light.
to give you 1.
I'm only
So
trying to
direct formula
make sure
or
I can do
traditional
this
method,
as
anyone you
quickly
guys
as
are used
possible.
to,
For
just make
full
sure
concept
what
video,
you are
they are
solving
available on the
is
channel,
absolutely
which you
solved
can watch.
well.
So what we do is we
I hope you
incident what?
understand
Basically, we use a
and
45-degree prism. I told you about that. The
So
reason is
we
just
move
because
to the
of what?
next
The
question.
critical angle. If you are following our series,
About the next
you will
question, we
definitely
have
understand
a
all you know
ray
what you need
of
to know
light
to
is
pass your
incident.
examination.
A ray of
So
light
when a
is
light is incident on this, the way we perform this,
at
single
an
way, let me just
object
teach you
on one face
directly.
of a
It was
glass
incident to the
prism.
glass. It is coming
I hope
from
we are
air
here.
to glass.
What is
Glass
the
is
angle
denser
of
than air.
deviation
We
of
say it
the
is going to
ray
be
as
minimally
it passes
deviated in
from
air.
air to
As
glass?
you can
A
see,
ray of light
it
is
will move
passing
something
from
like a
air to
straight line
glass. So
here.
we've talked about
That's a
glass now,
minimum
and if we
deviation.
are just
In
training
fact, we
those,
call that
now this
particular
is
point I
the
wrote
situation we
45,
are trying to talk
the
about.
angle of
Let me
deviation.
be quick to change the
Then when
diagram
it
and give
comes out
way
now, it
for
is inside the glass.
visualization experience.
It wants to
Now
come
let's
out.
take a class
It
lab
will
to
bend towards
understand this.
normal.
We're
It
going to
will
pick a
bend away
class
from
lab and
normal
we're going
because
to
it's
draw
moving from
like this.
glass
Now
now
we
to
have a
air.
class lab.
So which we've talked about diffraction. So
So for
now
you
the
to
only
see
difference
that
here,
a
I
ray
think
of
I've
light is
fixed that,
incident to the
is
glass
that
slab,
it
I
will be
can refer
refracted,
to
which we've talked
my
about in triangular prism.
normal
So
arrow.
the ray of light are now going to
Now
be
let's take this
separated
as the
inside
normal
this
ray as
point.
usual.
If we extend
We have
this
talked
line
about
the
when
way
a
we
ray
do
of
it
light
in
is
junior
incident,
classes, and I
it is going
continue
to
to
be
look
what?
at this, you can see
Refracted. So let's say
it will be
incident ray.
splitted up. Then your
I've drawn
teacher
a
can
square.
also tell you that, okay,
It
fine.
is moving from
Inside the
air,
glass,
vacuum,
another way
air,
to
vacuum,
understand concept
air
is that it's going to split
to
up. Wow.
glass. This is the glass. What
Then
happens?
it's going to
Let's
split
dense
up
or
and you
lighter
have
medium to
this.
a
So
denser
there are
medium. It's
two
going to
different
bend towards the
conditions
normal.
now. The ray
The
of
ray
light
of
has been
light will bend
splitted because it's a
like this towards
monochromatic
the normal.
source. It will now split up to
As it
7
continues
different
to
type
go
of
here,
color.
what
You guys
happens? It's
are
going to emerge
used to
from here.
Roy
It's
B.
going to come
I
out.
think I am
Don't
right.
worry about grammar.
I'm
If
used
grammar
to
is your
before I always start from the back. ROYGBIV. Yeah, you call it Roy B. Now, all these 7 different type of color will now be produced by a white light, which we take as a monochromatic. So I have asked those mostly academic people not to disturb me about time. So today I think I'm a little bit safe to take my time and explain what I think is important for you guys to get, because I believe it is my understanding. So, but in this kind of situation, we are still going to see that some colors are overlapping. That is, they are actually entering into one another. So we say they are now arranged according to their speed. Now, this white light here is said to have been dispersed to give you all these 7 colors. This is red. You choose the second one: orange, yellow, green, blue. I only show red and violet. So when white light, which is a monochromatic source, is dispersed, it's going to give you 7 different colors you call Roy beef. Now, this Roy beef, or the separation of the dispersion, you can see the word disperse, seed disperser, biology student. In your germination topics, you might have studied that as well. So disperse is just splitting around. So it has split white light. So inside white light, we say there are 7 other colors, which we call color of rainbow. So rainbow is formed by as a result of dispersion of light. I'm only going to take this one in an elementary way, because in advanced we also we define a property we call Cauchy principle or Cauchy formula. Now Cauchy was able to, but I don't want to go into that. Let me just make it simple and basic for what is going to be asked. So be that as it may, and my point is dispersion that we have now talked about now in a simple way. You can just write a simple note of going forward, because I may see questions. I will still ask. Dispersion is due to 2 things. And it is 2 particular things that makes this white color to disperse. The first thing you can keep in mind is what the color are moving with different speed. Different speed corresponding angles are equal in glass. In fact, that is exactly what Cauchy formula is talking about. Different speed in glass. And the second reason why white is giving you 7 other colors, which you call colors of rainbow, let's take a basic, is because of different thickness of gas, which we call different refractive. What's the plural of index? Indices. But if I'm writing indices, you are saying index, you're just talking about singular and plural. So for a particular monochromatic source, what do you now call monochromatic source now? White light. What is a monochromatic source? A light that has what? A color that do not overlap. So, and those particular thing is called what? A pure spell. So my point is, dispersion is occur because of all these colors are moving in different speed, and they are moving with different refractive index. So if we talk about that, the arrangement of each of them according to Cauchy formula, I think some question used to ask you, but your teacher might not tell you it is called Cauchy formula. It's like the speed, the change in speed in glass. This is data. V means speed. You have learned that in your kinematic and mechanics. The change in speed is proportional to the change in wavelength of different speed. Wavelength is lambda. You have also learned that in your concept of waves and wave motion. All these stuff, sorry for those one making bookings, all these things is now inversely proportional to the change in deviation. All right, deviation as for now. So change in speed or is what is the same thing as change in whatever, which is similar to change in deviation, or you say change in refractive index. I'm saying forget about all this, because your elementary level of understanding physics is what we are dealing with, because your own is not going to be detailed. So I don't think I need to talk about too much of details. It's only for you to know that this Roy field you guys, your teacher have made mention of in your junior classes, and when white light is dispersed, it's going to give you 7 different colors. These colors in form of rugby are arranged in their what? In their order of speed and wavelength. For example, we say red, you can say now rugby. I told you guys are used to rugby. I'm used to what? Victor. As in, I'm coming from the back. It's the same thing. Rugby is common here in Nigeria. I think Nigerian students are used to what? Rugby. In Ghana, we are not used to rugby. It's Victor. So note. So now, for the basic that I am actually making this video in Nigeria, I'm going to use rugby, and let's take rugby. Now, for example, what it means is that red is what? Is having the highest wavelength. So here you can say this order of rugby is in their decreasing power of wavelength. Decreasing wavelength. When I say decreasing wavelength, I mean also decreasing speed, because I said speed is proportional to wavelength. You understand? At least red is more of higher wavelength than what? Orange. Orange has higher wavelength than Yellow. Yellow has higher wavelength than green. So this one has to compare which of the following is mostly what has the highest speed. Red is more speed than what? Orange. You understand? Either wavelength or speed, it is decreased. That is, it is going like you are using Waec. So speed or wavelength will take that. So you can say I'm taking time on it because I just want to talk about the concept, a quick concept, so I can answer question very quick. I hope you guys are here. So the thing about this type of question is that their wavelength and speed is decreasing if you are using Waec. But in terms of their deviation, for example, which one is mostly deviated from the light? You can see it's violet. Violet is coming downward most. So if in terms of deviation, violet is more deviated. Like deviation means the one that is far away, from the light. Look at where violet is. Violet is most what it has what highest deviation. So if you are saying this is decreasing wavelength, what happened? It is now what increasing deviation. Increasing deviation. Some of you have issues with language. Language wise, you don't understand concepts. Let me break it down for you. I mean, red has highest wavelength than orange, and so on and so forth. Are you there? Now, the same thing also happened in terms of what? If you want to talk about in terms of their deviation, violet has more deviation than what? Now, if I ask which of these out of red is the least deviated, what's the answer? Red. Red is the least deviated. Why is it the least? Because it's the first one you are going to see. It's very close to what? To the light. So, but violet is very far away from. So if I compare which one is more deviated between green and blue, what will be the answer? Blue is more deviated than green. I hope you understand this. It's just about wavelength is decreasing, but deviation is increasing if you are using Waec. The same thing is also possible for when you use a rectangular prism we call a class slab. I'm sorry, time is always the major constraint. I'm not supposed to teach. In fact, this was what Cauchy actually used for this experiment. We have talked about refraction also take place in this, because you can see questions that relate to this as well. So when the ray of light is incident, we've talked about it on glass, here to glass, it bends away from normal. And I say when the change in direction of light, the bending is now called refraction. So the ray of light is coming like that. Let me just say, supposed to have lift my hand like this. So the ray of light is coming like that. Then when changing phase, it's going to bend away from normal. So it can bend like that, and all other ones are also going to bend. The other one that is coming, you trace it just like what we've done, and bring down one like this. So we talk about the same thing. Light ray can also disperse red and violet. Like others will not be orange, green, blue, indigo, just like what you have here. So, but what we see here is that color of light are going to overlap. They are going to enter into each other. So because of that, we can't see what we produce is called a pure spectrum. So to produce a pure spectrum, we use what? We don't use a rectangular prism. Let me answer the question now very quickly. We use a triangular prism. Then to actually make it very pure, we now place, you can take a note, we place a convex lens. I told you convex lens is also called converging lens. Convex lens before and after the prism. So if I ask you now from what I've explained, how do you make a pure spectrum? Triangular prism. What do? You place a convex lens. So one convex lens will be placed here, another convex lens will be placed here, then the same diagram you draw is for you. Why are you placing convex lens? So that the ray of light I want to escape will be absorbed. Convex lens converge ray of light. They are converging lens. The other type of lens, concave lens, what? Divert. So you don't use a diverging lens if you want to calculate all the color. You don't want them to escape from the glass. So you use a convex lens. So you place a convex lens before and a convex lens after the prism. That is how to achieve that. You don't use this, you use this. So let's answer the question. Sorry guys, I have to take you through a lot of things. That is my way, and that is the best way I believe you can teach. You can't just say you want to answer a question whether you have an idea about it. You have to have an idea about what you want to answer. And if you still have time, you can watch the full concept video, but the full concept are very large because it's mostly for advanced students O-level student can also learn what is needed out of it. They are in what? In checklist. I said they are in timestamps. You can always check the particular one you needed. Now look at this. The arrangement which is used to attain a pure spectrum of white light is that a source, that is where something is coming, source. A seat, that's a small space. A prism, a converging lens, a screen. Now, I said what? Before the prism, you put a converging lens. After the prism, you put what? A converging lens. Then all the image will now be absorbed where? On the what? On the screen. You understand? Because you are seeing screen there. This thing is hanging. Okay, fine. On the screen. So note, this is the screen where when you take all the color. Now, my point is there must be two converging lens. That's what I'm talking. One before and one after. There is a source, that is where something is coming from. There is a slit. There is a converging lens. There is a prism. You can see converging lens is convex lens. Before the prism, look at the prism, converging lens. After the prism again, converging lens, then all image are absorbed what? There is a source, that is where the what? The light in the monochromatic source is coming from. So the right answer to this question is option C, and that is the correct answer to that question. Sorry, apologies. I took a lot of time on that one because I want you guys to rest. Then the next question, I think this is a direct question. A blue flower appear blue in the sunlight because that. Now this will take us to mixing of color and what we call color of object. Maybe I still need to talk about one or two things here as well, please. To talk about one or two things.
So now all the ray of light will now be absorbed by this. It will now, all the ray of light, the refraction will now be in this direction. So we say it has now been reflected.
What like we have.
Now you can remember that this is the incident.
Now we classify colors in two categories: color of an object.
This was the incident. In this case, it was not 90 here. This was the refraction.
Color of an object. Basically, they are classified into what? Primary colors.
So be careful about this. Is the refraction.
And what secondary colors?
In this case. Now, my point is this particular.
I think that is important for you also to know. Now, when we mix two or more primary color, we form about secondary color. In fact, for those that are fine artists, they will tell you there's another thing we call complementary color and harmonious color. These are fine art stuff. But in physics, we only limit ourselves to what is needed, especially for your level. Like I said, I don't need to talk extremely to what is not needed. I will take a simple diagram and I will explain primary color for you guys right away now. Red, blue, and green.
What we are having is what? This is air. The air
RBG.
now taken all the refracted ray.
I hope you have studied primary color in your junior classes, and if not, there's a first time to everything in this slide. Now, when you mix red and blue, we say we have magenta,
you need to keep in mind,
which is a secondary color. When you mix red and green, you have what they call cyan. No. Red and green will give you.
Next thing you see that
don't let me make mistake. Red, blue is magenta, which is more like purple. Blue, green. Red, green will give you yellow.
Fast a little bit, so the ray of light will now
and blue green will give you cyan. No, I think I am wrong. Sorry about that. Red green should give you cyan. Don't mind when I make mistake, I easily spot it out. And blue green will give you yellow. So these ones that we are forming by mixing. So next time you see question, magenta is equals to what plus what now? Magenta is what? Red plus blue. Please, you don't need to sleep on black bike. You have to watch. You have to jot what you are saying down. Is important. Don't sleep now. Please, you have to jot them down. Then if you say cyan, which is a secondary color, is a mixture of let's say red plus green. I hope you can see what I'm doing, guys. Then if you have blue plus green, it is what? Yellow. Many students do fall a mistake of thinking red, blue, and yellow is primary color. It is red, blue, and green, and they are classified under color of an object. Now, there is another color which most of us do make a mistake with. That is the color we call black. I am just taking this thing in a quick way, fastest way, black. When you talk about black, in fact, in physics, we say there is no color called black. Please note that. And why do we say that? Because from our knowledge of dispersion of light, we understand that the only time you can form black coloration is that when what? All colors, you can just write all colors
Let me use the blue now. A glass
has been absorbed. That is when you see black. For example, like this simple question we are facing before. For example, now if I say a mixture contains, listen guys, a mixture contains blue and green. And I say when you mix, for example, look at this simple mixing of color, because blue plus green now is now mixed with green. And I ask you that which color will be seen. That is, you mix blue plus green with green. What is the color that you are going to see? The answer is what? Green. Why is it green? Because green color is common. And we say because green is common, green is going to be what? Reflect. I hope you are communicating, you are getting my point. So any color that is seen by your eye is said to have been reflected to your eyes. That's where you are seeing it. So when no color is reflecting to your eyes, you said all the color has been absorbed, and that is when you have black. Look at another example. If I have red plus green and I mix it with yellow,
that is why they are setting.
Now, if I ask you what is the color, red plus green mixed with yellow, what is the color? Is there any common color here? The answer is what? Black. Because no color is common, right? Here, what happens? Color is common. The addition is what? Green. I hope you are getting all this explanation. Now, look at red plus green plus yellow. What is the mixture? When I mix it together, what will be my answer? Black. Why is it black? Because there is no common color. None of the color is reflecting to my eye. All the color has been absorbed. That is when we get black. I hope students understand that, and that is the basis of what we have here. So that's the concept of this. A blue flower appears blue in sunlight. Why do you see something blue? Because blue has reflected to your eyes. Transmit blue light. No. Refract. It's not refracting. I said it's what? It's reflecting. Absorb blue. If it absorbs blue light, you are going to see black color. Now, reflect blue light is correct, and the answer to this is first D, which I've explained the concept in just a few times. So let's increase our pace. We have 12 questions. This is just the second question. We have a long way to go. We move to the next slide. On doing that, I have to take water just for us to answer the next question.
We use a 45-degree prism because of the critical.
Yes, I'm back. A narrow beam of white light, a narrow beam of white light in air is incident on triangular prism. The color that explains the greatest deviation. Look at it. We talk about it here. That's why we just pick answer. See, when the narrow beam of light is coming, it will be what? Dispersed. Red has the highest wavelength. Violet has the highest deviation. Then I say which of these is mostly deviated? What? So it is out of all this answer that we are going to pick the one that is far. Deviation means the one that is mostly far away. Just always keep in mind your Roy what? Roy B. So about your Roy B, what do you think the answer? This is the answer that has the highest what? Deviation. Violet has the highest deviation, and thank God in the option. But in some cases, I may decide not to pick violet. If violet is not in this option, let's consider three other options between red, blue, and yellow. Which one has the highest deviation? The answer is what? Blue. You can see blue is the next in terms of deviation. Deviation is what? Increasing like this, whereby speed and wavelength is decreasing. I hope students understand that. I think this is a very simple question. Which of the following colors, which of the following is a primary color of light? I think it's a cheap question with the academic team. Thank you for giving us cheap question this time around. We'll talk about R, B, and what? And G. You can see what I'm talking about. You guys will say yellow. Yellow is not a primary color. So out of all these options, these are primary colors. Red,
minimally deviated because it's moving from
blue,
to glass. Now it is now moving
and green.
What do you expect?
So note that yellow is formed from what? It's a secondary color and is formed from missing what? Two primary color. I told you we classify color into two parts: color of object and color of pigment. I have given you color of object red, blue, and green. I said magenta, cyan, and yellow. Now that's color of object. A pigment, filter. You know what they call filter? That is mixing of different type of color. So color of pigment. In color of pigment, we also classify color into red,
now incident, refraction, incident
blue,
one, incident two. You know this way as it was
and yellow. May I see yellow? Yes.
So we say
but you won't be able to see it because it's not deep.
Prism angle. So now we define another
concept
we call minimum deviation.
I just want to bring something. You don't mind
now.
and yellow.
We say
Yellow is so light. Some people cannot see it like that. Sorry, open your eye and see it. Red, blue, and yellow are classified on colors of filters. Or if you like to say pigments, the way you guys are used to understanding it in junior classes. This is color of object, primary color.
The angle between incident.
So what are secondary color? How do you form secondary? They are colors that are formed by mixing two or more primary colors. Because of those of you doing Waec students, definitions are also important for you to know. Now, red plus blue now is now purple. For filter now, you know what for filter? This stuff is hanging purple.
This is angle of refraction of 3.
Red plus yellow is now orange.
We know that we can say now A,
and blue plus yellow is now green. Remember this one, cyan.
So we say the prism
magenta is magenta. It's not magenta. I'm talking like a Yoruba man now. Then blue plus green is yellow. So you have to memorize this because it's important in some cases. This is a simple question. I'm only taking you through simple concepts you also need to keep in mind. I hope I can move on. Which of the following is the primary color? What's the answer to this one now? Orange is not the primary color. These are primary colors, and these are secondary colors. These are colors of filters or color of pigment. So yellow is not the primary color. White contain all these colors. Never be primary color. Red is a primary color. Answer to this is choice D. I hope students understand that, and we move to question number 5. Please, understanding matters. That is the essence of watching all these video concepts. Yes, we have filters, and I think we have to mix now. There is a diagram. In the diagram, X, Y, Z are yellow. My dear students, X is yellow, Y is red. I'm reading through the question, and cyan. Where Z is cyan? Cyan.
1/2, that's half.
Now, light filters, especially a white object viewed through the filter would appear dash. Now, what are the colors of white objects? My dear students, we've talked about that. White contain how many? Excuse me, guys. Waec.
Triangular prism. To solve question on triangular prism, you have to
look at where the eyes is now. So we want to mix color. Listen to this because it's one of the most important aspects. I think only dispersion for your level. Most of the questions that is asked are cheap question, and these are the way you see them for your standard. Now, in the diagram above, X, Y, and Z are this. Now, let's start. We start from here. White has ROYGBIV. Hope you understand. White has 7 color. We've talked about that. ROYGBIV, Roy B. Then it was now viewed through X now. Plus X. What does X? X is what the color what? Color yellow. So what is common now? If you mix Roy B plus yellow, what are you going to get, guys? The common color. What's the common color? Yeah, yellow. When there's no common color, what's the answer? Black. We've talked about that. Please, you have to follow. So I have mixed it through X. The answer I get was what? Yellow. So yellow is the answer at X.
That is why I'm taking my time.
Plus, what is white color? According to the question, red. Yellow plus red. I will now say A. Yellow plus red. Yellow plus red. Can I miss yellow plus red? Come here. Check. Yellow plus red. Yellow plus red. See. Yellow plus red. Yellow plus red. Yellow plus red. Color of filter. Yellow plus red. Can you see? Yellow plus red is giving me what? Orange. For color of filter, yellow, red plus yellow is what? Orange. Red plus blue
over refractive index of water.
Red plus blue is magenta, which is also purple.
From glass to, you can say that of glass. I told you.
Then blue plus yellow is what? Is green. I hope students are getting this. So what am I doing here? I'm only trying to go back to this. I don't actually need it because there are things that I'm used to. So yellow plus red is going to give me what now? Orange. Let me start all over again for understanding's sake. White object contains 7 different colors. It was viewed through what? A yellow filter. When we add colors together, we go for the what? The common color. When there is no common color, we go for what? Black. So the next thing is what? Okay, the answer for the first filter with white object was a yellow. Yellow was now viewed through red light. So if we put yellow through red light, we are having what? Orange. Now, this orange is the answer at this point. Was now viewed through cyan. The third color Z here, they said it was cyan. Now that means we need to know what cyan stands for.
I'm going to continue from
We
this
now
side
go
for
back.
understanding's sake.
Look at cyan.
1.86.
Cyan is a mixture of what and what?
1.33
Red plus
what have I done, my
green.
dear student?
I hope students can see that. So that means you need to know this color wheel by heart. So now you come here. Now say orange was now viewed through cyan, which is what? Red plus what? Plus what? Green. If you have forgotten, I'm showing you every step. Cyan is red plus green. So now, if you are not careful, my dear student, you say there is no common color. You go for black. It's a lie. Orange is a mixture of what color? Orange itself is what? Yellow plus red. I hope students are following. It's now mixed with what? Red plus green. What is the answer now? Yellow plus red plus green. What is the answer? Common color. What's the common color here? Red. I hope students understand. And that means the eyes that is viewing this thing here is going to see a red color. I hope you understand that, because it's very important to understand concept, and that is what I have done. White has 7 color. When you mix color together, the common color is what you're going to write. And after you have mixed them together, there are different filters. All of filters was used. Cyan is red plus green. Orange is here, red plus what? Yellow. So red plus yellow was mixed with red plus green. The color you are going to see is going to be. So you take them one by one, then you mix them. And if there is no common color, the answer will be choice A, which is black color. The next question. About the next question, my dear students, which of the following statement is not correct? Not correct. Please always use question well to understand. Dispersion is the phenomenon by which light bends round corner. Yes, they bend round corner. I told you how dispersion is being done. Triangular prism, right? Then it enter, it's minimal, then it start, you can see it's bending. I'm even bending my head right now so that you can understand. That is very correct. Is what you can define dispersion as a process of bending round corner. Dispersion results from different speed in glass. I told you there are 2 conditions that are responsible for dispersion: different speed and different refractive index. You've written that in the first page. This is it. I will show you. I've told them that they should free me to actually use my time. The dispersion is due to different speed and different refractivity. So that second statement is also absolutely correct. Look at this first statement. Now, guys, if you are following, you can answer it. The violet component of light has the lowest speed in any refractive medium. What do we use? Roig-B. That is also correct, right? Which one has the highest speed? Red, followed by orange, followed by yellow, followed by, as you are going like this, you say it is the green. Look at this statement. Violet component of white light has the low. When we say white light is Roig-B. Are you communicating? Are you getting my explanation? So this is also a correct statement. So I don't need to read the last statement. That means it will be the what? The answer to the question. So the answer to the question: all components of white light travel with the speed. They travel with the same speed. No, you can see different speed. That is why white light was able to do what? If there is no different speed, white light won't disperse. So this is the question answer, my dear student. I hope you all understand this, and that is that about that. So guys, that is that. That is the question number 6, I guess. We move to the next page, and about the next page. For those of you that you are slow writer, that is why you can as well download the videos and watch it over and over again on your YouTube page. Now we move to the next one. You leave a space. If you have not written it finished, you can always come back to it later. Next question.
Which we are still going to talk more about on optical instruments tomorrow.
Can we continue? Dear students,
we can also say here,
I hope it is a yes. Which of the following pairs of colors gives the widest separation in the spectrum of light? What is the separation? ROYGB IV, right? Roig-B. So which of them has the highest separation? Let's see. Red and what? Violet. We are talking about the gap. See, red and violet. That's the answer. No doubt about that. Red and indigo. See, red and indigo is not as wide as red and violet. Green and yellow. See, green and yellow, my dear student. Green and yellow is even rubbish arrangement. It's very close. Look at this, yellow and violet. Yellow and violet is not as wide as red and violet. So it's a simple question which I believe you all can answer. The next one, the dispersion of light by a glass prism is due to, look at what we've talked about. Dispersion is due to 2 things. What are the 2 things? Different speed and different refractive index. Look at the options here. Different hidden colors. Absolutely wrong. Different speed of various color in glass. Cauchy. Correct. Question answer. We don't need that. Defect of glass. Please, defect of what? Defect of lenses is called spherical aberration. Now, high density, all these ones are just rubbish, which you may not need for your level for this question. So that's that about that. We move to the next question because of time. We have to save time. You guys can always come back to it and rewrite them. If I'm a little bit fast, you can watch over and over again. And by virtue of what I'm saying, by what I always tell you, it's always best for you to just write what I'm saying. You don't need to write option or anything. You can write question and just put the answers there and put some other things that you heard me saying. That is what you need to know. So that's that about that, and that is that. We move to the next question, which is question 9, I guess. Now let's answer this together. Let's answer this together. White light is passed. This is the same concept. That is why this topic is one of the simplest topics. White light is passed through a glass prism. The red ray are less deviated than violet ray. Yes. What again? What are you going to write? Roy B. Or Roy B. rather. Now, red has the lowest deviation. Violet has the what? Highest deviation. Red has the highest speed and wavelength. Violet has the lowest speed and wavelength. That is just what you need to know. Now, what are they saying? They said red rays are less deviated than violet rays because velocity is speed. Please note that. Velocity of violet light in glasses is velocity of violet greater than velocity of red. That's a lie. Red has higher speed than violet. So this statement is wrong. Violet velocity of red glass is greater. This is a correct statement. Angle of incidence of all these things, because when you are talking about dispersion, my dear students, dispersion is talking about different speed. Dispersion is due to different speed and different refractive index. So two things are what are responsible: different speed and different what refractive index, which we have taught. So we are just repeating same concept. Index, so which we use mu. Some of you use n. I told you in the last topic of refraction of light about how this has been. So all other options here, velocity of red is always greater than that of violet in any medium. Velocity of red is greater than that of violet. Look at her, very good. Velocity of red is always greater than that of violet in any medium. Angle of this option here is wrong. Now, the question might be, look at this one, very good. I didn't even read that. Velocity of red light in glass is greater than that of. Now, we are only talking about glass because dispersion takes place in glass prism. It is not that we are talking velocity of light is always of red is always in every medium. That's a big lie. In glass, different speed in glass. That is why dispersion of four. So the answer is B and not E, because I know Waec students very well. These are where they have challenges when asked looks more like the same. In sequence, we move to the next question. I think it's question 10. Which of the following correctly explains why a green leaf appears green? You have done something like this. How do you see green? Because green has been what? Reflected. And all other color has what? Has been absorbed. So green shows because of reflection. Green is reflected to your eye. And what? Other colors. We've talked about this. Next question. I think this is the fifth. Are absorbed. I've talked about that in question 1, and we've talked about question like this. Look at it, it's a multiple choice question. It absorbs only the green light. No, if it has absorbed only the green light, that means what? You would see color black. You won't see green. So this is wrong. A leaf appear green in a beard. What? A green leaf appear green because green is reflecting to your eye. It absorbs all colors in sunlight except green, right? Correct. Because all colors have been absorbed, but green color is not absorbed. Very correct. It reflects only the green component of light. Very correct. I mean, reflects green and absorb other color. That is it. You can see Roman figure 2 and 3 is correct. And the answer to this is choice number D, or choice option D. Option D. So that's that about that. We are going to move to the next one. And the next one is the last page for this section of dispersion of light. And about that, we have this. A mixture of blue and red pigment, when illuminated by white light, will appear dash. What do you know, guys? Color of objects, color of pigment. We've talked about that. My triangle is too big.
it will come like
color of
this.
object, I gave you the
Straight
color
line.
with
Normal means
red,
perpendicular to the
blue,
surface. You understand? So normal
green,
incident follow the same pattern.
magenta.
Which
You
is
can see we are only
yellow.
repeating the same
Now,
thing.
the refraction can follow. Two
Cyan
things is going to happen. Now let's just
and
take
yellow.
this as our
And the other color I gave you this. Only repeating the same concept over and over again, but it's good. It's increase your confidence and boost your mark.
Now,
Red,
normal incident that is coming like this, we continue to come straight
blue,
line.
and yellow.
Now here refraction
Purple, which is the same thing as magenta.
is in two ways.
Purple, green,
because we have
and orange. You have written this before. I just wanted to see what the question are. Blue and red pigment. Blue and red. Red and blue. This is color of pigment, right?
Now,
this is color of what?
Towards normal
Objects.
or bent away from normal. Let's do a
So
little
from
bit of
here,
geometry.
when a blue and red pigment are illuminated, they are viewed from each other. See, what they're asking is what is red plus blue? So what is red plus blue for pigments now? Is equals to what? For
and maybe we call this
purple.
one
So it's a simple
Z
question.
degree.
So the light is what? When a red light is viewed under a blue glass, it will appear what?
From our
For
knowledge. Now,
purple.
but let's look at the
So
way
the answer is
this
purple.
is coming.
And that's about that. The last question, which I think is based on the same concept we just talked about in the previous slide. This is a sheet of white paper viewed through a red glass appear red because why are you seeing red? Because red is reflecting to your eyes and other colors has been what? Absorbed. So it's the same concept. The glass reflects red color is the correct answer, and that is what that's about that. So guys, I think this is where we are going to stop on dispersion of light. I think we are done with slides for day for now. I think the next in your syllabus, if I'm not mistaken, is electrostatics. Stay with us for the best of what physics video. Like I said, I'm going to do all concept, all video, all chapters in your syllabus with respect to your syllabus for excuse me, O-level students. So I'm done for today. If you find anything interesting, kindly subscribe. What we do is what you are going to learn for weeks and months in your various schools and coaching center are going to be taught within one and a half hours in details almost the academy. So I'm not saying you should not go for your classes or tutorial centers. They are very important. But one thing you still have to keep in mind is you have to come and do this kind of work. Watch all these checklists and invite your friends to also watch, because if they also watch, they have the tendency to watch to do well or perform well in the fourth form examination. I'll see you soon. I'm Engineer D. Bye for now.
You guys know that very well. So hope you understand.